Good morning all. Power supplies in parallel again. I've got two of these Buck Boost LTC 3780, I think it's called. Power supplies paralleled up on their outputs at the positive of this supercapacitor triple bank. Ground is all the blacks and the greens. I'm going to set this one to a lower current and this one to a higher current. Oh, my meters are all switching off. That's interesting. I want to set this one to about 0.5 amp. So I want this one to charge the supercaps when they're fully charged, because their protection circuits can only offset about 0.5 amp. This one I want to set to much more current, but this one will be on while these are charging up. And then the minute one of these three protection circuits comes on, these little red LEDs, I turn off the high current charge power supply and just leave the low current charge power supply to bring up the two remaining caps, because inevitably one of these caps will get to 2.5 volts before the other two. These little lights on the power supplies are on, but only by virtue of the fact that the outputs are cabled up to the supercaps. I'm not using any diodes here. I could put blocking diodes in the two outputs. Red is the high current output, yellow is going to be the low current output, but I haven't done that. It's just all wired up in parallel. Let's see what happens. Now I'm measuring the voltage, there's a V there, of the supercap bank. That's 3.2 volts. That will be 7.5 when it's fully charged, and these two meters are showing current amps coming out of the two power supplies. So I'm just going to switch this one on at the moment and set the current, because I haven't set anything yet. Just switch on my lithium power bank. So that's a bit high, that's 1.3 amps. Let's turn that down, which I believe is this middle one. If I can get the screwdriver on it. Yeah, so I want that to be 500 milliamps, so that that one can stay on all the time. Because I know that, oh, a little bit overcooked it. I know that these circuits can offset that 500 milliamps. So even when this gets up to the full 7.5 volts, we're okay with that. But then I want to add this one into the mix on a higher current. Now, I've no idea what this is set to, and I've no idea how these are going to respond with their outputs paralleled. Now, all these crop clip leads are these horrible thin ones. So they're kind of acting as fuses, so if something goes badly wrong, I'm hoping the wires will die before any of the electronics. Actually, I'm just going to pull this lead out. I've got two of these, but I'm just going to put it in this other one so that I can set a suitable current. So that's on 0.5 amp. Let's up that. And get this thing in the slot. Let's go for about 1.5 amps, so there's a clear difference. Okay, that'll be fine. Right, now I'm going to parallel these two up. Now this one's got the on-off switch, so if I press the switch, it goes off and the fault light comes on. There's a run pin on the LTC 3780, that is its name, isn't it? Yeah, and if you pull it low, which is what that switch does, it just stops the chip running. So let's turn that back on. I'll find the other lead and I'll parallel these up and we'll wait for the bang. Right, I'll just switch the power unit on. Now the first thing I'm not sure about is how these two units will current share if they're both powered up and both supplying the supercapacitor bank. We'll find out, I guess. Power on, DC on. They're on. Oh, that's not good, because that's gone to negative 1.4 amps. And that's gone to 2.6 amps. Now that's interesting, and I think I know why that is. I'll back this one off a bit. Oh, this is really fiddly getting this in the little adjuster. Oh, that's not backing off. Oh, it is. Oh, that's gone a bit sudden. Ah, yes, there's some interrelationship between these two, because as soon as this one kicks in with a decent current, that one goes negative. Yeah, that's quite interesting. I'm not sure how that likes having negative current forced back into it. But yeah, they're behaving really strange. Now I've got other pots here, of course. I've got the voltage pot. So I'm going to make sure that's high enough that this thing is going to keep kicking out current. I think it is. But yeah, that's interesting. I wonder if the outputs of these are going to need diodes so they don't interact with each other. Okay, so if I switch this one off, like so, that one is now its original setting. Now I think that the reason this is now putting out twice the current I set it for is because of the way these power supplies measure current. They measure it with a little low value resistor. Well, of course now they've got two of those low value resistors in parallel, so it's going to be measuring the wrong current. Yes, that's right, two of these in parallel. It's going to get less voltage across that resistor, and therefore it's going to need to put out more current in order to measure what it thinks is half an amp. Yeah, that's interesting, and we could probably prove that by just unclipping that momentarily. Oh no, it's in the earth circuit, isn't it? It's in the 0 volt circuit. So if I take the 0 volts off, yeah, that immediately drops back, this one immediately drops back to half an amp. Connect up the grounds, because the interesting thing about the minus, the ground output on this power supply and the ground input is that they're not common. There's this current measuring resistor between them, so that's why this is putting out the wrong current. But having said that, this kind of still works. I guess if I adjust the current on this one to half an amp with the duff resistor in there, we're getting half an amp. And if I turn this power supply on, this one goes to 2.5 amps and this one goes to minus 1.7 amps. Yeah, interesting. Capacitor voltage is coming up though. One of those meters is about to go off. But that supercap bank is coming up really slowly, and I'm just wondering whether 1.8 amps of that 2.5 is actually being lost somewhere. There's no heat on this, it's completely stone cold. There's a big aluminium slab heatsink on the back of this, completely stone cold, so I don't know where that heat's going. Are these hot? No, they're not hot, but this just seems to be coming up really slowly. I suppose if I disconnect the positive from there, oh, these cables are all quite warm. Will that come up more quickly? Oh, that does seem to be coming up more quickly. So I'm not sure whether this is going to work unless I put, oh, that's dropping down, look. Now that I've put that back, I think I'm going to need to put blocking diodes in the outputs of these two power supplies so that they don't do this interacting with each other thing. Now let me just explain why I'm doing this. I've got a project which was going to use supercapacitors to power a Bluetooth speaker, and the Bluetooth speaker part of the project is all done, but the supercapacitor charging is what's held that project up. And because everyone says you should finish projects, I want to try and finish this project, but that requires that I have a charger for this supercapacitor bank. And I want a dual stage charger. I want one that charges quickly at first using a high current, and then when the first of these three capacitors reaches its maximum voltage, this one shuts off. And that can be done by taking these little LED signals, putting them through opto-isolators, and effectively turning this power supply off. And then this power supply takes over, putting half an amp into this. That brings up the other two capacitors, and the cap bank is fully charged. That allows the supercapacitor to really exploit its main feature, which is fast charging, so that you could charge this supercapacitor Bluetooth speaker in a few moments at a high current, and then this one tops it off so that the caps are all balanced. Ignore these active balancers, they aren't really doing anything, and they're not going to do anything. They won't be there in the finished design, because the protection circuits will top balance these capacitors anyway, because as soon as one reaches 2.5 volts, the protection circuit comes on and just holds it at that voltage while the other two come up to meet it, so that's top balancing effectively. Well, it will be a relatively easy thing to get a couple of diodes and put them in the outputs of these two power supplies. Yes, there'll be a small diode drop, but that doesn't really matter because the voltage in this system is defined by the capacitors, how far they've got charged. So these power supplies are set to some arbitrary voltage, something above the maximum voltage of, what is that saying fault? Oh, it's because this one's switched off. Something above the maximum voltage of the pack. So eventually I want 8 of these caps in series, so it'll be a 20 volt pack. These things will need to be set to about 22 volts or 24 volts to make sure that the supercapacitors reach their final target voltage. Oh, 2 of these have switched off. Okay, let's switch them back on. Right, I can only find one diode just quickly. But that might be good enough actually if I just put that in the power supply, which seems to have this strange negative current. That should protect that from happening. So screwdriver, let's take that off. I think these are switched off at the moment. And pull out this little wire, which is actually a cut off of one of these diode legs. Anyway, let's put the anode into there. And clip that back onto the pointy end, the cathode. Right, let's power this all back on again. Power on, DC on. So we've got backfeed into this one, but I don't think that'll matter when it's off. I think the backfeeding is only an issue when it's on. So we've got 0.5 amp going into the supercap bank. That's creeping up slowly. Let's now turn this one on. That's gone to 2.3 amps and the voltage on the caps is going up quickly. That one's gone to 0 because it's protected by my Schottky diode, which you can't see very well because it's under the yellow crop clip. So yeah, that seems to be working. And oh, yo, red lights have come on. So I now have to switch off. That's interesting. Why has that gone to less than 500 minutes? Oh, I wonder if the voltage limit has kicked in on that one. So switch this one off because some of these caps have come up. I've got a bulb on here which I wanted to prevent the middle cap coming up, but actually that's probably causing more trouble than it's worth. So let's take that off. I just wanted to hold this pack down, but that's not really going to work if I'm only effectively shorting out the middle capacitor. So these are way out of balance now because the middle cap's probably near 0. Yeah, why has that gone to that lower current? Is there something? Ah, yeah, it's the voltage limit. So I'll raise the voltage on this. That's now current limiting. With the current limit pot, the middle one, I think the bottom pot is the voltage adjust pot. 500 milliamps is going in here. You may not be able to see it very well, but the first and third caps are up to voltage. It's the middle one which isn't, and it must be very low because these balancers haven't come on, so they're obviously not getting enough voltage to function. But yeah, that's pretty good. So if I briefly put 2.5 amps into there, that's going to overrun those protection circuits, so I don't want to do that for too long. But that switches between 2.5 amps on this one, nothing from there. Turn that off, and that one kicks in at 0.5 amp and tops these off. This, I think, could be the solution to charging the supercapacitor powered Bluetooth speaker. Let's let this one come up to full charge. Yes, that'll still be drawing 500 milliamps even when this is fully charged, because it's all being offset in the 3 protection circuits. So that won't stop drawing. We can see where it is actually, because 2.5 plus 2.5 is 5, so this one must be at 0.75 volts. That's got a long way to go to charge up. So now all that remains to do is to somehow send these signals back to this shut-off switch. Now this shuts off if you put it low, so putting opto isolators on here and paralleling all the opto transistors so that it's a logical OR, if either of these three caps turns this LED on, the opto transistor will pull to ground, and that'll pull that to ground, switching that off. So that will work really without any additional electronics, just three optos parallel up the transistors. Can't parallel up the LEDs because they're all at different potentials on this supercap bank. And in fact, when I've got 8 supercaps, I'll have to have 8 opto transistors all paralleled in a sort of open collector. The first one that switches on turns this power supply off type of arrangement. I'll draw that at some point. So my question now is, can I put an opto LED, because I'd like to keep these red LEDs because it's very useful to see when these things get up to 2.5 volts. So can I put an opto LED which is infrared, will have a lower forward voltage, can I put it in parallel with a red LED? The red LED I realise will be a lot dimmer if it comes on at all, but it might come on just enough to see it. I will try that in a future video. So while that supercap bank's coming up to 7.5 volts, I'm just going to sketch what I think the issue is with these currents being wrong. So the PSU, so there is a PSU block, it has a plus input and a minus input, and a minus output and a plus output. But now there's lots of gubbins between the plus output and the plus input, of course, but you'd expect the minus output and input to be joined together, but they're not, because there is a low value resistor. Now can I see what value it is? Yeah, R007 it says, R007. So that might be 7 milliohms between the output and the input. That means that when current is flowing, now current will flow that way, won't it? Yes, so this point, really? Will this point be higher than this point? I was convinced it measures in the low leg of the... Yes, I suppose it would, wouldn't it? At all points, the voltage here is going to be higher. Well, anyway, you'll get a slightly different voltage on one side of this resistor to the other, and then an op-amp somewhere in this circuit is measuring that tiny voltage. And because it knows this resistance, it's converting that into a value for current flowing, and that's how the current limit circuit limits the current to half an amp. But put two of these in parallel, and we effectively parallel up this R007, creating an R0035 resistor. Right, one of the active balancers has come on saying, I've finally decided to fire up because I got enough overall voltage, and I've decided that the middle cell is at a too low a voltage, so I've switched on both my balancing circuits, thus pulling in some charge from the outer two cells to try and pull that middle cell up. This one's finally burst into life as well, so that actually will assist in raising the voltage of the center supercap. But as I say, active balancers are not needed on supercaps. They're always going to be out of balance until they're finally topped right off, and then they're balanced by virtue of their protection circuit. So they kind of got balancing built in anyway. Still got half an amp. This one's still off. I can't really turn this on because it'll shovel too much current into the supercap bank. I mean, I could do it briefly just to show that the low current power supply turns off, and then that turns back on again. This is a perfectly good solution to the problem. I've just bent this diode down so that you can actually see it in circuit with the half amp power supply. Getting towards 6.5 on the caps now. Of course, it's burning off most of this current because it's burning off half an amp at 2.5 volts there, so that's however many watts it is. Another half an amp at 2.5 volts there. All we've got is the half an amp at a bit less than 5 no, 1 point something volts on this middle cap that's being taken in as charge. Yes. These power supplies, there's no anti-backfeed diode in here. When they shut off, when all the MOSFETs are off, I think I determined once before in a video that they don't suffer any ill effect, any bad effect of the potential for current to flow backwards through it. It just doesn't, because all the 4 MOSFETs are switched off, so there's nowhere for that current to go. So you don't need these blocking diodes. But because this one went to minus 1.7 amps, yeah, that's a bit of an issue, and there was that strange interplay between these two. This one wouldn't come up, and then suddenly it did, and this one went into reverse current. Yeah, better to have that diode in circuit, clearly. So this is the first of the projects that I've brought out to the new... I've done a couple of videos in here, but this is the first one that I've brought out to the new electronics workshop. And the advantage in here is that... oh, I think we're going to lose several of these meters now. There is a way to lock these on. I think you have to hold a button and turn it on, but I haven't done it. So these projects can live in their place and they don't need to be packed away. It was the constant packing of everything away which I think hampered my project development. So I will find a place for this project. It will just stay there on the bench. I might take the DVMs in each night, because it's not a good idea to leave anything valuable in a shed. But yeah, projects will just sit in their place on the bench. I might even screw things down, because I can screw down onto these deck boards. No worries. It's going to be a much more productive environment. So it doesn't make sense to put this across the middle cap. It's just that it sits in there quite neatly, so I don't have to hold it. If I put it across all 3 caps, it lights up quite bright. It's a 12 volt bulb, and we've got, well, 7.5 volts on these caps when they're fully charged. That of course pulls the voltage on the supercap bank down, although the middle cap should be dropping in voltage less quickly than the outer 2 caps. So we are getting ready for a state of balance. Actually, now that that's dropped a bit, I can put on the higher current power supply. These lights are now on, so that has to go back off. And now we're back to 0.5 amp charging the supercaps. I'm not going to finish this video until these are charged. The sun's come out, which is why you've got this massive wash of light down on the floor here. That's my foot. But fortunately this area has the light moderated by the walls of the workshop. And a quick shameless plug for my workshop or shed building channel, Julian's Shednanigans. I'll put a link down below. If you want to see how I'm building this new workshop, then head along to that channel and take a look at some of the videos there. I told you it was going to be shameless. So I've just gone and got an opto isolator, PC817. Now, pin 1 is anode, I think, and pin 2 is cathode. So I think it's going to go that way across these LEDs. And I just want to see, and it's going to be a little bit tricky, whether the LED still lights if I put this opto LED in parallel with the red LED. You've got to be a bit careful here. No. It goes completely off, which is a bit of an issue, because I do like to have those red indicators, but if I put the opto LED across the red LED, of course this pulls that voltage down, and then there's none left for lighting the red LED. So I'm going to have to solve that problem. One in series with the other. I just feel that the volt drop's then going to be so large that it won't turn the protection transistor on. I don't know. I shall have to work on that one. Maybe I put the opto LED here, and then although we wire the opto transistors in parallel, maybe I pull this circuit, this pin of the chip, down to disable this chip through the opto transistor, but also through a visual LED. There should be enough voltage here. I think it's 5 volts, and yeah, there should be enough to pull that down and have an LED in circuit. Oh, maybe there isn't actually. I've got a feeling it says in the data sheet you have to pull that down to 1.5 volts. I'll have a think about that. I just have one other idea, and that is to put a blue LED directly across the capacitor. Doesn't know if I get this wrong, does it? But I've got a feeling I've tried this and they... Oh, yes, that does light. That does light on that one. And yeah, not on that one. And it does light on that one. So that can be the indicator. A blue LED directly across the capacitor. And then the opto in this position in the circuit, which can then do the shutting off of the high current power supply. Well, there it is, it's fixed. And, oh, these lights are starting to go off. So that center cap, I think actually the light, no, but that's just about to come on because this is just coming up to 7.5. And it's up to 7.5 volts, but the protection LED for the center cap actually hasn't come on yet. The blue LED, which I've just wedged on the 2 terminals there, is on very faintly, and I'm hoping that when that LED comes on, oh, it is starting to come on, that the blue LED will be a bit brighter. But yeah, that works really well as an indicator to tell you when these caps are up to 2.5 volts, and it's completely separate to the protection circuit, so the protection circuit can now be switched over, oh, I dropped an LED, to using these optos to shut off the high current power supply. Well, that's it, it's finished. I've finished the design of the power supply for the supercapacitor Bluetooth speaker. Now I've just got to sort of build it and implement it, but that's fine. I can do that with this now left on the bench. I can come and work on this project whenever I want. Excellent, these 3 lights are on, the indicator's on, job done. Cheerio.